The greatest common factor, otherwise known as GCF, you'll see that a lot, is the greatest or highest quantity that's a factor of all of the integers or polynomials involved. So how do we find the greatest common factor? You can find the greatest common factor of a list of integers or terms by writing each number or polynomial as a product of the prime factors, so prime factorization. Then identify any common factors to all of those in the list, and then take the product of all of the common prime factors. If there aren't any common prime factors, then the greatest common factor is just 1 for labeling purposes, but we would never factor out a GCF of 1. So find the GCF of each list of integers. Our first example, we have the numbers 12 and 8. So the first thing that we need to do is prime factorization. So any two factors of 12, say 6 times 2. 2 is a prime factor. 6 is not, because 6 can be factored down to 3 times 2. So now I have the factored form of 12. 3 times 2 times 2. I want the factors of 8, so any two factors, say 4 times 2. But 4 isn't prime, that's 2 times 2. So 8 can be written as 2 times 2 times 2. So now I'm going to identify all of the common factors. So let me start with the first factor in the first number. There's a 3. Is there a 3 in 8? No. So I'll move on. The next factor, 2. Is there a factor of 2 in 8? Yes. So I've identified one common factor there. And then the last factor of 12 is 2. Is there another 2 in 8? Yes. So I've identified another common factor. There are no more factors in 12, so there could not possibly be any more in common. So now that I've identified all of the common prime factors, I'm just going to multiply them together. 2 times 2 is 4. So the greatest common factor of 12 and 8 is 4. Example 2, we want to find the greatest common factor of 7 and 20. So 7 is a prime number already, but 20 has factors of, say, 5 times 4. 5 is prime, 4 is not, because that's 2 times 2. So 20 is 5 times 2 times 2. So the only factor in 7 is 7. Is there a 7 in 20? There is not. So that means that there are no common factors between 7 and 20. If I had to list a GCF, that's just 1. Some more examples here, finding the greatest common factor of a list of integers. For number 3, we've got numbers 6, 8, and 46. So 6 is 3 times 2. 8 we just factored is 2 times 2 times 2. And 46, well, that's an even number, so it divides by 2, and that goes in 23 times. 23 is actually a prime number. So those are completely factored. Now I want to find the greatest common factor for all 3 numbers. So let me start with the first factor of 6. Is there a 3 in 8 and 46? Nope. Then the last factor of 6. Is there a 2 in common for all of the numbers in this list? Yes. And there are no more factors in 6, so there could not possibly be any more common factors. So 2 is the GCF for those 3 numbers. For number 4, we have 3 numbers again, and they're pretty large numbers here. So factors of 144 is 12 times 12. And 12 we already factored is 3 times 2 times 2. So each of these has a 3 times 2 times 2 factor. So 3 times 2 times 2 times 3 times 2 times 2, those are the prime factors of 144. 256, that's an even number, so I could divide that by 2. That goes in 128 times. which also divides by 2. That goes in 64 times. 64 is 4 times 4, and 4 is 2 times 2, so a whole bunch of factors of 2 here. 1, 2, 3, 4, 5, 6 factors of 2. Then prime factorization for our last number. 300 could be 10 times 30. 10 is 5 times 2. And 30 is 10 times 3. So that gets us our prime factorization of 5 times 2 times 5 times 2 times 3. Lots of factors here, but we need to see what factors are in common. So if I start with the first factor, 3, is there a 3 in 256 and 300? Nope. There is one in 300, but not 256. It has to be common to all. So next factor, 2. Is there a factor of 2 in 256 and in 300? Yes. And another factor of 2 in both 256 and 300? Yep. I know there's no factors of 3, because I already checked that. Is there another factor of 2? Oh, there is no factor of 2 in 300. So I can't count that one. And there's no more factors, so those are the only possible common factors here. 2 times 2, which is 4. So the GCF for those 3 integers is 4.